Good morning, scientists. So today's topic is all about telescopes. So when you're learning about telescopes, there's different types of telescopes. You've got the refracting telescope and there's also reflecting telescopes. So refract means to bend light. So right here, I've got my camera that I usually use to shoot some of these videos. And it's zoom lens here. I have the zoom lens attached to it. But the lens on here works where you've got one lens in the front and then you got another lens in the back. Actually, it's got a few lenses in between too. But it bends or refracts light as it passes through. So if I take the lens off here, just like this, you could almost see right through it. And there's a lens down here at this end, and there's another lens up at the other end. So as light goes through there, it gets refracted. So I can zoom in and make the image bigger, or I could go the other way and make the image change so I have a wide angle as well. So scientists will use telescopes with different types of lenses to gather different amounts of light, and depending what they're focusing on. So just like a camera lens could focus on something far away or close up, that's what a refracting telescope does. It has two or more lenses in it. Now, even this, you might say, oh, Mr. Schulman, that's not a telescope. You're right, it's not a telescope, it's a microscope, but it also works with refraction. You've got two lenses, one down here, another one up there. So this one's on a stand, but look at that, it's off the stand. So now, it's sort of like a little telescope. And if I look through the eyepiece, there's one lens here, there's another lens there, or I can switch it to one of the other lenses here. And it works the same way. So these things, telescopes and microscopes, were invented at about the same time. So they invented lenses and they said, well, we could put two lenses together and we can make something to focus on something very close and small, or we can make a larger version that could focus on things very far away. So I'll put this back on its stand over here and put that off to the side. Now there's the other type of telescope, which is a reflecting telescope. Now, when scientists were using refracting telescopes and with all these lenses in them, one problem with a lens is as the light would get split, once you started magnifying it a lot and splitting, the more you split that light, just like a prism splits light into the different colors, the lenses do the same thing. And you end up with a light getting split and the colors separate. And you get really fuzzy images, or the images look all purple around the edges, or you get different colors that aren't really there. So the more you magnified it, the image quality really went down in quality. So then they decided to use mirrors. So this telescope right here has a mirror on the inside. And I think I've showed this to you before. You can see the reflection of my phone in the camera now. And there's a couple mirrors. So there's a mirror all the way in the back here. So it's a curved mirror. So all the light enters the opening here, hits this curved mirror, and then it reflects back to the front. And there's a smaller mirror in the middle right there. And that smaller mirror reflects, it gathers all the light and reflects it up to the eyepiece over here. So reflects it right into back there. So you kind of see inside there. And then this is just a little mirror that bends it and reflects it back up to this lens. So this is a combination of lenses. So there's actually one lens up here and another lens up here. So this telescope is actually a combination of a reflecting and refracting telescope. That's why it's so small. So they've kind of combined a lot of different things here. If I'm looking at the moon or the planets, this is great. I could even hook my camera up to this and film wildlife far away. So this works for some basic stuff. So when they use mirrors to collect light and magnify things, you don't have any bending of the light so much. In other words, the light doesn't get refracted or split to the different colors. So you get a better image. So if I wanted to change the magnification, I could simply take off the eyepiece and put a different eyepiece on, and it's going to magnify a different amount. So that's one way I could change the magnification, is just by changing the eyepiece here. So different eyepieces are going to give me different amounts of magnification. Now, one of the other things that they use to describe telescopes is the aperture. So the aperture is basically how big the mirror is, how big the opening is in the front of the telescope. So this one, the mirror is back here. So this one, it's about 6 inches. So this would have a 6-inch aperture. If I was looking at my camera here, camera lenses are measured by the aperture. There's an opening inside there. And you can actually probably see this a lot better back here at this end, and how the size of that opening refers to the aperture, how much light it could gather. So I've got another lens over here. Let me grab this one. And this lens over here also has a much bigger aperture. And that one has a bigger opening, so it can gather more light. So usually I record my videos with this little lens here because it gathers more light. So if I'm filming indoors or recording something inside, it's much easier to see. I can get a better image because this one collects more light with just 1 or 2 lenses here. So that's what the aperture is. The bigger the opening, or the bigger the mirror, or the bigger the lens, the more light you can collect, and you can get a bigger, brighter image. So the aperture is one of the most important parts of any telescope. So it doesn't matter what kind of energy, what kind of electromagnetic energy you're gathering. So if it's radio waves, like these radio telescopes over here in this image, which is from way out west, I think that's in New Mexico or Arizona. The aperture is just basically how wide or how big that radar dish is. The width of that would be its aperture. So the bigger the telescope, the more radio waves it could gather and concentrate and detect, stars that are giving off that radiation. So whether it's radio waves, microwaves, gamma rays, X-rays, ultraviolet, infrared, all of these different things are gathered with telescopes that are going to have some type of dish or lens that's going to gather all that information, reflect it all to a sensor, and then that'll be processed through a computer to make an image. And we could learn all kinds of things about stars and planets far, far away. So just like earlier, we were learning about how stars have different temperatures and sizes. We use telescopes of all different types to gather that information and learn more about them. Even black holes. Black hole, it's dark, you can't see it, doesn't give off any light, but it does give off X-rays and gamma rays, and that's the way we can detect those things. So those are all different types of telescopes. And some of these things, like for example, like infrared and X-rays and gamma rays, not very much of that electromagnetic radiation reaches the Earth's surface. So we need to take and launch those types of telescopes into orbit, put them out in space. That way there's no atmosphere distorting the image. Even using light telescopes with lenses, if we have them here on Earth, as we look through the atmosphere, it distorts our image. You might have seen that where like on a hot day, you're looking and you see sort of a mirage, or there's distortion and you get wavy lines as you're looking down the road. Well, the same thing with the atmosphere, especially here in Florida with all the humidity and the heat. As we look through the atmosphere, there's a lot of distortion. So by putting telescopes out into space and orbit around the planet, we don't have that distortion. So that's why the Hubble Space Telescope gets such great images, because it's out in space. There's no atmosphere to distort. But none of those things were out in space until after 1957. So most of everything we know about astronomy before 1957 was all done with just telescopes and using the naked eye for observations here on Earth. So today your job is to, there's a brain pop about telescopes, watch the brain pop. Also on the link in the module about telescopes, there's a few questions there. As you're watching the brain pop, answer those questions. Now, if you paid close attention, I also answered a lot of those questions during the course of this video. So you can always go back, watch this again, and pause it in a few spots as well. So go ahead, answer those questions, and then you have a quiz to take today. So what you did yesterday, the chart about the electromagnetic radiation, there's 7 different types, use that chart so you know what types are what order. So you have radio waves have very low energy, and then gamma rays have very high energy. So know which ones have the lowest energy, which ones have the highest energy, know what order they're in, use that chart on the test. So you get 2 opportunities for the test. Also use the questions and notes that you created during the brain pop on telescopes. All right, so good luck and stay curious.